Hi guys, welcome to today's tutorial on level 3 chemistry spectroscopy. Today I'm going to go through some practice questions just to get you just to help you to do well in this particular internal. Now there are mainly two different types of questions, which I will go through about 4 questions altogether, where you can have a look at how how to approach these type of questions. Okay, so first of all, I have the resource sheet up here. I normally you will get given something like this for the internal, and I kind of know these by heart, so I don't really look at them so much. So but you feel free to take a screenshot and you can use it for the next bits of an activity. Okay, so let me just find the documents. Let me drag this one over here. Okie dokie. Alright, so let's look at this first question. As you can see, I didn't leave any answering space because I want to display all the spectra and the question together. For your ABC, is mainly just looking at what you can see from each spectrum, and then for D is tell us which one you have selected to be the correct answer. Okay, so let's start with it doesn't matter which spectrum you look at, I just start from whatever I got given. Okay, so for the NMR, so this one's NMR. How do I know it's NMR? Because it's parts per million, that's a unit, and there are 1, 2, 3 peaks. So 3 peaks means 3 carbon environments. Okay, so that's the first thing first, and this tells me I have a C double bond. Okay, so that's 2 clues already. And this, look at the IR, this could be OH, this could be NH, I don't know what it is. It's not registering, so that's okay. And then this peak over here is C double bond. Or again, just refer to the resource sheet. And if you are still struggling with this, have a look at my previous video on the tutorials about just how each spectrum works. Now looking at the mass spectrum, now remember this is the one I spent quite a bit of time on. This long peak is your M+ molecular ion. The reason for that is that this peak over there, this is your carbon-13 isotope peak, and we need to ignore that, okay, because that's, can you see it's 1 unit to the right and it's really insignificant, so we ignore it. So this is the molecular ion is 73 mass ion ratio, so the molar mass is 73 grams per mole, and that means you will have at least 1 nitrogen. So if you have at least 1 nitrogen, that means over here this is most likely an NH. Okay, so that's pretty straightforward. Let's just, because remember we want 2 things from each spectrum, and that's 1, 2, that's done. That's 1, 2, that's done. For the mass spectrum, that's 1, 2, and you can also talk about there's no CL, there's no BR, because there's no 3-to-1 or 1-to-1 isotope peaks. So let's have a look at this. So straight away, this one's wrong. Why is that wrong? Because that doesn't have nitrogen. This could be okay. This is wrong. Why? Because it doesn't have a nitrogen. This could be okay, and this could be okay, and oh, that's not okay because this has a chlorine. We don't have a chlorine. And for this one, so it's either this or this, but I know it's not this one because it doesn't have an NH bond. Because if you look at the IR, I have an NH bond right there, so this is the correct molecule. Okay. Oh, actually, excuse me, I forgot there's a possibility here. All right, so now we need to look at the other parts. Now let's look at the carbon environments. This is 1, 1, 2, 3. This is 1, 2, 3. So each of them has 3 carbon environments. I have a strong suspicion, and now this just comes down to experience, because I know the molar mass is 73 grams per mole. And the last thing I told my class numerous times, I don't want you to calculate the molar mass for every single one of them because that's just time consuming. But can you guys see this V? This has 1, 2, 3, 4 carbons, whereas this one has 1, 2, 3 carbons. So the molar mass is going to be quite different. So if you look at this one, the CH3 is 15 grams per mole. It's carbon is 12, H is 1, nitrogen is 14, and oxygen is 16. You'll be provided all these. You don't need to memorize it. Okay, so let's add it up. So this is 15 plus 12 plus 1 plus 15 plus 12 plus 16 plus 16. Okay, so that's 15, 27, 28, 43, 55, 55, 71. Okay, so this is looking a bit too heavy. So why don't we look at this one? If we look at that one, that's 15 plus 12 plus 16 plus 14 plus 1 plus 15. So this is 27, this is 30, so 57. 57 plus 16 is 73. Okay, so this is the correct molecule. So what we want you to be able to do, and you may struggle at this last step, because you go, oh, they have the same carbon environment, they have the same everything, you know, they look, if you look at this particular bit of the spectrum, you may go, wait a minute, there's nothing too significant here, there's nothing too significant here, how do I determine which one of these two is the correct one? Well, in this case, they have different number of carbons. If they have different number of carbons, they have different molar masses. Okay, and that's when you can just calculate these two and then quickly figure that out. So the way that we want you to, especially at my school, we want you to be able to eliminate, like say for example, you can just say it's not II, it's not IV, it's not II, it's not II, it's not IV because there's no nitrogen. There's not I because there's no NH. There's no VI because there's a Cl. Okay, because from our spectrum, it tells us we do have a nitrogen from the nitrogen rule. We do have an NH, which is on this particular NH on the IR spectrum. And that only leaves us to these options, and I calculate the molar mass. I know it's going to be III. Okay, so that's the first one. Next one. Excuse my handwriting. So maybe if you want to take a screenshot before I attempt the question and even give it a go yourself, that will be quite ideal. Okay, now next question. See this says the molecular ions 116. Make sure you read it. Don't just go straight, oh, this is the molecular ion because that's the furthest right hand side peak. You're on the right track, but I already told you the molecular ions 116 is too weak to be observed. So the molar mass is going to be 116 grams per mole. That means you could have, if you look at the nitrogen rule, you could have 0 nitrogen, 2 nitrogen, 4 nitrogen. You're not going to get any more than that. Okay. And are there any chlorine or Br isotope peaks? Nope. There's no Cl. There's no 3-to-1 peaks. And Br, there's no 1-to-1 peaks that are 2 units apart. Okay. So this one tells us that. Let's look at the IR. IR. This is a CH bond. Not exciting. This is a C double bond O. That's it. There's no OH. There's no OH, there's no NH. Okay, look at the NMR. There's 1, 2, 3, 4, 5. So there's 5 peaks. 5 peaks means there are 5 carbon environment. 5 carbon environments. Oops. Environments. And if you look at the spectrum, if you look at the chemical shift, this is a C double bond O. If you look at 70, 70 is normally a 50 to 70, which is a C single bond O. Normally, okay? Normally. But this is what I meant. Like, you can just briefly write it down on the spectrum, or one way that I tend to do it before, which also works quite well, if just to look at the just look at the selection first. Okay, just look at the selection first. One thing that if you could do really quickly, you can just do the carbon environments. You can figure out the carbon environments. This is 1, 2, 3, 4. This has 4 carbon environments, so that's wrong. Why? Because I have 5 peaks, I have 5 carbon environments, so straight away that one's wrong. And this is further wrong because this has a Cl, and we clearly said there's no Cl. And this one is 1, 2, 3, 4, 5. That could work. This is 1, 2, 3, 4, 5. That could work. But can you guys see there's a CC double bond? I don't have a CC double bond. CC double bond will be in this region, so that one's wrong. This is 1, 2, 1, 2, 3, 4. So this is 4 peaks as well. Now, if you wondering why these two are the same, so think of it this way: if I have the CH, and then C double bond, so if I rearrange it, if I make it look like this, Can you guys see it's symmetrical down the middle? CH2, CH3, CH3. So these two guys are the same. These two guys are the same. So they're 4 peaks. But this is wrong. Why? Because there's an OH peak, OH bond, and then I said there's no OH on the IR, so it can't be that one. All right, so this is 1, 1, 2, 3, 4, 5. So that could be it. And this is 1, 1, 2, 2, 3. So that's wrong because they're 3 carbon peaks. All right, 3 carbon environments. So the only realistic option is this one and this one. You know, that without looking too much at everything else. But I know it's going to be this one. The reason being of this peak here. Okay, of this peak here. At 70 parts per million, that's normally a guaranteed C single bond ore, which is a C single bond ore. Okay, so this carbon that I highlighted is responsible for this peak right there. This carbon I'm highlighting now, this carbon is responsible for this peak. Okay, so that's how you can quickly do it. You know, if you can at least tell us what you see on the spectrum, that's normally achieved. And I hope I'm not going through this too quickly. Okay, so question 3, same type of question. So anything interesting here? Not in particular. Let's have a look. Okay, so this mole is 104. 104 means there's probably no, there's 104 grams per mole. That means there's most likely no nitrogen or 2 nitrogens. Are there any CLs or BRs? Ooh, this might look like a CL, but I may have to check on that. So that might be a CL, because if you, now remember for the CLs, they don't have to be right at the end. They could be as anywhere between 35 or above. So that could be a CL, so I'm going to question mark this. Okay, so I'm not too sure, because that, if you could zoom, if we zoom in, let's zoom in, why not? If we zoom in, you can see that this is about 3 times the height as that, so that's very suspicious. So I'm just gonna leave it there for now. Oops. Yes, I'll leave that for now, and I'll come back to it. That could be a CL. Okay. Now there's no OH, no OH, no NH, and if you wonder how am I coming to this conclusion so quickly, check out my previous video. Okay, so there's no OH, there's no CO. Okay, if we look up here, there's 3 peaks, which means 3 carbon environment, and this is 60. Okay, so that's, again, if you look at the resource sheet, that could be a carbon bonding to chlorine. So again, very suspicious. Could be a CL. That's really nasty to see. I mean, if we were to for us teachers, if we were to give you a question that contains CL, I wouldn't give you this one because that's too nasty. Okay, but again, one other reason that kind of makes me suspicious of having a CL is, look over here. Can you guys see that has a CL, that has a CL, that has a CL? That's like, that's rather suspicious, isn't it? Like, why would there be 3 molecules with CLs in the equation? But that's just, you know, you don't want to. Again, you can do what I do, just quickly look at the spectrum, or you can quickly look at the selection and then, you know, go from there, but that's really up to you. Okay, so straight away we know this one's wrong because there's no BR. This one's wrong because there's only 1 nitrogen. We know there's no nitrogen. We know there's no NH, so it can't be that one. It can't be that one because this has an OH. So realistically, and it's not this one. Can you guys see there's a C double bond O? So that's not that one because there's no C double bond O on this particular group. So that means only we are left with this or this. And that means, can you guys both see there's a CL? So yes, there's a CL in there. So yes, this is a CCl. This is the chemical shift for the carbon in that particular molecule. Okay. So carbon environment. This is 1, 1, 2, 2, 3. So that's 3 chemical shifts. 3 peaks. Sorry. This is 1, 1, 2. So this is going to be the correct molecule. Okay. Now, when we're wanting you to write the justification, you do need to tell us why each one is wrong, just briefly. Like you can say I is wrong because it's a C double bond, or IV is wrong because there's a BR, there's no CL. You can just say IV, III, and V are all incorrect because there's no CL, which from the spectrum, I can see there's a Cl. And then how can I justify it? And then this one's wrong because this one has 2 carbon environments. And then this molecule that I'm highlighting right now, this is correct because it has everything right. And then just go through the list. Just tell us, yes, it has 3 peaks, it has a CCl bond, it weighs 104 grams per mole, it has no OH and H, and it has no C double bond O, which agrees with all the spectra. Hence, that is a correct molecule. Okay, so that's the type of question that you're most likely going to get. And I think there's one more here. My background. So this is the last type of question. Now this one tends to be a little bit harder, and if we give you questions like this, we normally don't want you to we don't give you really difficult ones. Okay, so this is figuring out everything from scratch. So what that means is that we don't give you a selection, we want you to figure it out. Just look at the 3 spectra, use the clues we give you, figure out what the molecule actually looks like. So as you can imagine, this will be a lot harder because you can't eliminate the ones that are, you know, so obviously incorrect. You actually have to come it up with yourself. Okay, so they all relate to the same compound, and let's find out. We want to identify the compound. So first thing first, this is 60. So 60 grams per mole. That's very important. All right, now we have 2 peaks. This is a C double bond O. So 2 peaks. So at least, so what does that mean? So 2 carbon environments. So that means we have at least 2 carbons. Okay, and then we also have at least an oxygen. Let's look over here. This looks like an OH, and this looks like a C double bond O. And then you may go, how's that? How do you know it's not an NH? Well, I mean, it's 60 grams per mole. You have 2 carbons at least. You also have an carbonyl group. You know how if it's an even number, you either have 0 nitrogen or 2 nitrogens. Mathematically, you're not going to fit 2 nitrogens in there. Okay, so if you see this broad peak and you know you're most likely not going to have a nitrogen, this is most likely OH. Okay, so let's combine it together. We know we have a C double bond O. We know we have an OH. We know we have 2 carbon environments. We know they weigh 60 grams per mole, and you can kind of see, can you guys see this functional group over here? What's the functional group that you combine C double bond O and OH together, which is a carboxylic acid? Okay, so that's kind of what you can do there, just by, you know, combining them together. You have to know your functional group. We would tell you there's only, like, say, if there's 1 functional group, because otherwise it could make it quite difficult, because I could make a ketone and put the hydroxy group somewhere else, and then that would be quite difficult to find out. But then once you master everything, I know that won't be a possibility, because I look at my NMR already. I look at the carbon, I can't have a C single bond or anywhere. But you know, just C double bond carboxylic acid, COOH. So let's figure out this. Yeah, so we know we have 2 carbons minimum. We have 2 oxygens minimum. So that, because there's O here, there's an O here. So that means this is 24 grams per mole already, because each carbon is 12. O is 16. So this is 32. Oops, I say 32 and write 36. Okay, so this is 32. So what's that added together? That's 56 grams per mole. How many, what is it out of? My total mass is 60 grams per mole. So that means it's about right. I can't have any more else. So it should be 2 C's, 2 O's, 4 H's. Because 60 minus 56 is 4 grams per mole, and that will be 4 H's. Okay, and if I were to draw it, it will just look like this. And then that will match everything that's on the spectrum, because you have your C double bond O, which is here, and which is here. You have an OH bond, which is here, and then you have 60 grams per mole, which is the molar mass, which is here. You have no nitrogen. You have 2 carbon environments, which is right here, and that is your correct answer. Okay, so obviously I've given you a very easy one, because we normally don't give you anything too difficult, and it's all about the way to approach these type of questions. Okay, so let's say, all right, let's just make a new sheet. All right, so what if you know you have 2 carbons, you have 2 oxygens. I'm just gonna make it up. All right, so this is 24, this is 32. All right, because each C is 12, O is 16, and this is 56 added together. Let's say, what if your molar mass, what if your molecular ion is 80? I'm just making it up. I don't even know if this works. All right, 80 mZ. So what does that mean? It's 80 grams per mole. So by having the bare minimum of carbon and oxygen, you got 56, you know, assuming it's the same type of equation, it's 56, but I know the molar mass is 80. And this is where you need to think about it. All right, so what's 80 minus 56, which is 24? Are you realistically going to have C2O2 and 24 hydrogens? No, that's not going to be the case. So this is where you need to go, all right, so it probably can't be 20, that 24 is too big. What if I add another carbon? So instead of 2 carbons, I have 3 carbons. Because remember, the NMR tells you the carbon environment number. It doesn't tell you how many carbons there are. So you could have multiple carbons being displayed as one peak. Okay, so if we do, instead of using 2 carbons, let's do 3. 3 carbons will be 36, 32, and then there will be 68. Remember, I made up this 80, so this could be a wrong number. So it's 80. So 68. 80 minus 68 is 12. I mean, C3O2H12, again, this probably doesn't exist, but can you see that looks much better than C2O2H24? So it's all about just trying to figure out, if you get this type of question, when you get to the last step, just figure out how many carbons and oxygens and nitrogens you have. Don't worry about the hydrogens, all right? So think about how many C's, O's, and N's you have minimum and add that up together. And then look at your molar mass and then compare them. If they are really close, that means you can just need to add a few hydrogens, then you're done. Or if they're really, really far away, like the one that we've done here, that means you need way more carbons than what we just did. Add another carbon, like say we figure out the difference is 24. You can't just add 2 carbons because 2 carbons is 24. Okay, because you can't just have C4O2, that wouldn't be right. That where are the H's? That wouldn't happen. Okay, so most likely just add 1 more carbon and then the rest are hydrogens. But that's to do with more of these type of questions, and I know some schools probably don't even do these type of questions. I think we normally don't anyway, but it's just good. Just this is much harder in comparison, and so yeah, I hope this has been helpful. Just 2 videos on spectroscopy. It's really I love teaching and I love doing spectroscopy stuff because it's like solving puzzles, and I hope you do well in the internal if you haven't done it yet. Okay, feel free to leave a comment or subscribe, and just let me know if you need any assistance, and just leave in the comments and I'll give you a hand. Okay, so hopefully that was helpful, and yeah, and I'll see you guys next time. Bye bye.